This data may not look exactly like yours, but it should be the same data. You should have joules of work performed, calories, um, the distance the person traveled, their force. And so you can arrange this how you want. But before you do anything else, please go to row 2 and I use 2 fingers or whatever you need to do to insert a row above. Why? Because we need to add data for 0. So if you do 0 work, that means you've burned 0 joules, 0 calories because you haven't moved at all and you don't have any force, right? 0 times 0 equals 0. This class data, what we did was we figured out the force. So everybody has their own force based on their weight. And then everybody just chose the distance they wanted to move their force up the steps. And so we have this large range of distance covered. Hard to find a trend when you have this much variability in force and distance. So what we're going to do is we're going to make the distance everybody move the same. It's difficult to change everybody's force, but we can change this pretty easily by putting formulas into sheets. For the formula, force times distance equals joules. So instead of doing all these by hand, that would be insane. Let's add a column, joules, and let's make the sheets do the work for us. So in this space right here, I'm going to put the formula. So you go to here, f of x, and you are going to, work for me, there we go. You're going to put an equal sign, and you are going to say C2, which is distance, times, and that's a little asterisk, it's above the number 8, times D2 is what I want you to do right here. Look at that. And then it said suggestion, fill it in. Sure, let's do it. I'm just going to drag that down, and it just did all of that data for me. Okay, so you don't trust it? Take a look. This is an easy one to check. 10 times 362.8 is 3,600. So it does that for you. So if you look up here, it has the formula, C3 times D3. If you look here, the formula, C4 times D4. So if you set it one time and then you drag this down, it will automatically program that formula for you. Okay, you do it to your data. This is great, except we still have all this inconsistency. So now what we're going to do is we're going to change the distance everybody moved to something consistent. So I'm just going to say, let's all move 30 meters. So I'm going to put 30 in here. Notice that already changed here. I'm going to drag that down and tell everybody or make everybody move 30 meters. That automatically calculated the new joules. You could do it for whatever you want. Let's make them go 130 meters. And everybody's joules is automatically calculated now that you've put in the formula. So please set the distance to something consistent. You get to choose how far you want to make all these people hypothetically move. And then make sure you display the new joules that are calculated by your sheets. Now that you have made everyone cover the same distance, we are going to graph force and see how the force affects the joules. Obviously, it can't be the distance because everybody's going the same distance. So how is the force affecting the joules or related to the joules? So to do that, you are simply going to highlight force and joules and then insert chart. And we're going to pick scatter plot, not column. I can't even understand why they did that. All right, there we go. That looks pretty good. I need labels. So let's go ahead and customize. and just go to chart title and labels. And let's call the entire graph change in force and joules of work. That works. You can do whatever you'd like. So I know what I'm looking at. This is force and joules. Okay, let's change the title of the horizontal axis. So the x-axis, this is force in newtons. And then let's give the vertical axis a title. Again, that is work in joules. And if you really just want to abbreviate or just have joules, that's fine too. But there we go. Okay, we need a trend line. This is a scatter plot. It looks very linear, so we could definitely do trend line. So again, under customize, you're going to scroll down to series, trend line, and we're going to get the equation for that trend line. So let's go to label, use equation. Ooh, look at that. The joules would be equal to 130x plus, this is a really small number, that's basically 0. So slope is your distance in this graph. So please go ahead and do that for your data and make sure to label and have the trend line in the equation. This is really good information. The only issue is that we're not super familiar with joules, and in exercise physiology, we really are able to easily determine calories. So let's go ahead and let's delete this chart and let's add a column for calories. And again, it's not really a calorie, it's a kilocalorie, but there we go. Since all of our devices tell us calories, let's go with that. So keep in mind the formula, and again, we're just going to do 0 because there you go. But the formula for calories is your joules divided by 4,184. So let's put that formula in here and make sheets do the work. So same thing, go to f of x, and you're going to say equals, and you're going to go the joules. So this is E3 divided by 4,100, whoops, that should be, there you go, 184. That's what I want. Whoops, there's an error. What did I do? It does not like the comma. Hartford does not like commas. There we go. Okay, so that's our calories. And you saw the suggested, do it for everything. The answer is yes. I would like you to automatically figure out the calories burned. Okay, let's do the same thing. Let's graph force and calories to see how force relates to calories. Unfortunately, there's joules in the middle, and you really cannot rearrange this once it's been once you've programmed a formula. Trust me, I tried it. You can't do it. So let's go ahead and highlight force, joules, and calories. Insert chart. And again, we would like let's under setup, we want a scatter. What's it doing? Oh, up here, scatter plot. And I don't want joules and calories. I don't want two lines. I just want to focus on calories. So here's what you do. You go over here to series, setup, series, and let's just click this little 3 dots and let's remove the joules. So now all I have is calories. Okay. Make sure this is checked. Sometimes that doesn't appear. Use column D as labels and then calories. Okay, now it's the same thing. Let's go to customize. Let's give it a good title. So this time the entire thing is looking at force in newtons and calories burned, right? Let's go ahead and change the x-axis, the horizontal axis, and we're going to call this, again, force newtons, and we're going to go ahead and make sure the vertical axis has a nice title because this time it's calories, which is, again, kcals everywhere else in the world. Okay, so this needs a nice trend line series, trend line. We can get the equation, but keep in mind it's not going to show us distance anymore because you have to distance divided by, distance times force, then you divide by. So, okay, this is what you need, though, to show the relationship between force and calories. You should now have some skills to use and analyze this data in many different ways. So we made the distance constant, but what I'd like you to think about is personalizing this data for you. Meaning you have one force. Okay, you are somewhere here. So if this is you, how will the distance, a variation in distances, affect the energy in joules and calories? So you will keep the force the same, but you will change the distance, and then you will make some graphs that have some meaning for you. Like, how far do you need to move your body up and down those steps to burn X amount of calories? Okay, that's the challenge. See if you can apply what you learned, but this time make force constant.